Warahmatullahi wabarakatuh. In this section, we will study about line and distance. Let me start with the definition of a gradient. Gradient of a line which passes 2 points. So we have the first point, the coordinate of the first point is xy, x1, y1, and this is the second point, x2, y2. So the gradient is defined by m equals y2 minus y1, x2 minus x1. So for example, if we have 2 points, let's say the first point is 2, 9, and the second point is 4, 3. So the gradient is, so this is y2, this is y2, this is y1. So 3 minus 9 divided by 4 minus 2. So we get minus 6 over 2 equals minus 3. Next, we have the definition of angle, or you can also call it slope angle, and we usually call it by theta. It is the angle from the x-axis to the line. And we count it counterclockwise. So for example, if we have so this is x, this is y, and we have the following line. So theta is the angle from here to here. And if we have another example, let's say we have the following line. This is x, this is y. So the angle theta is from the x-axis to the line. So this is theta. And we also have the connection between the gradient and the angle. So we have the following relation: m is equal tan theta. Next, we have the following short theorem. So if we have two lines and they are parallel, then the gradient of the two lines, so let's say the gradient of the first line is m1, is equal to the gradient of the second line. If we draw it, let's say we have the following two parallel lines. Next, we also have perpendicular lines. So let's say we have this is the first line and we have this as the second line, and if we see the gradients of the two lines, then we will have the following relation. So m1, the gradient of the first line, times the gradient of the second line, it will be equal to -1. So let's see an example. So the question is to find the angle theta of a line with the gradient is equal to 1. So to find the theta, we can use the following equation. So now m is equal to 1, the gradient is equal to 1, so we will get tan theta is equal to 1, and we know the smallest value of theta, which makes tan theta is equal to 1. We get theta equals 45 degree. And let's say if we have another similar questions, but now we have m is equal to -1, so we can use the same relation. So we get tan theta is equal to -1, and if we solve it, we will get theta is equal to 135. So another example is, let's say we want to check two lines, whether the two lines is parallel or perpendicular. So let's say we have the first line is passing 2 points. So the first point is 1,3 and the second point is 3,7, and we have another line passing 2 points also. So the first point is 3,7 and the second point is 7,5. So first we can calculate the gradients of the two lines. So we have the gradient of the first line. We can use the following equation. So y2, so 7 minus 3 divided by x2 minus x1, 3 minus 1, this is 4/2, so this is equal to 2. And also we have the gradient of the second line. We can calculate with the same equation. So y2 minus y1, so 5 minus 7, and then 7 minus 3, so we get -2/4, so this is -1/2. So the first gradient is equal to 2, the second gradient is equal to -1/2. So from this we can see that if we multiply m1 times m2, so it is 2 times -1/2, we will get -1. So in this case the two lines are perpendicular. Next we will see some equation of line. So we have several types of equations. Equation of line. So to get an equation of a line, we can use first the following formula: y minus y1, y2 minus y1 equals x minus x1 over x2 minus x1. We can use the following formula to get the equation of a line if we know that the line passing 2 points. So next we can use the following formula: y minus y1 equals m times x minus x1 if we know the gradient of the line, and also we know that the line passing a point. Then we can use the following equation: y equals ax plus b if we know the gradient. So in this case the gradient is a, and this equation passing y-axis at 0, b. And also we can have the following equation of a line: ax plus by plus c equals 0. So this is the general equation of a line. And then from the previous meeting we also know that we can have the following line. So we can have x equals a, so this is vertical line, and we can also have y equals b, this is a horizontal line. So now let's go to see what is distance. So we have the following theorem in the book. So the distance between 2 points, so the first point, let's write x1 y1, and the second point is x2 y2. The distance is defined by d equals, we call it d, the distance. So this is x2 minus x1 squared plus y2 minus y1 squared. So in this example, so if we have 2 points, let's say the first point is minus 2, 3, and the second point is 1, 7, then the distance is so this is the x2 is equal to 1 minus x1 is minus 2, so minus 2 squared plus y2 is 7, y1 is 3 squared. So 1 minus 2 is equal to 3, so we get 3 squared plus 4 squared. So this is square root 9 plus 16. 9 plus 16 is equal to 25. Square root of 25 is equal to 5. Next, we have the following theorem discussing about the midpoint of 2 points. So if we have 2 points, so let's say the first point is x1, y1, and the second point is x2, y2, the midpoint, so the point in the middle of these 2 points, we can calculate with the following formula. So x1 plus y1, comma 1/2 x2 plus y2. So for example, if we have 2 points, 3 comma minus 4, and the second point is 7 comma 2, then the midpoint is 1/2 3 plus 7 comma 1/2 minus 4 plus 2. This is equal 1/2 times 10 comma 1/2 minus 2. This is 5 comma minus 1. So this is the midpoint. Next, the last theorem in this section. So the distance from, so now we have a point. Let's say the point is x0, y0, and then we want to count the distance to the following line, ax plus by plus c equals 0. So in this case, we calculate the distance from a point to a line. The distance is equal to d absolute value ax0 plus by0 plus c divided by square root a squared plus b squared. So let's say we have the following lines, and then we have a point here, so we calculate this distance. So this is d. So now let's say a short example. Let's say the point is minus 2 comma 3, and then we want to calculate the distance from this point to the following line. For x minus 3y plus 10 equals 0. So the value of d, we can use the formula. So we have absolute So this is A. Let me write it here. This is A, this is B, this is C, this is x0, this is y0. So the formula is ax0, so 4 times minus 2 plus b is minus 3 times y0, 3 plus c divided by square root a squared plus b squared. A is 4, b is minus 3, so this is 4 squared plus minus 3 squared. So if you calculate, the numerator will be equal to 15 and the denominator will be equal to 5, so this is equal to 3. So the distance from the point to the line is equal to 3.